Let us now try applying what we have just learned by sketching the graph of the function f of x is equal to x cubed minus 3x plus 2. So, let's begin. Step number 1 tells us to take the derivatives and the domain of the function. Of course, you have already mastered this. Using the power rule, we can now get the first derivative, which is equal to 3x squared minus 3. Furthermore, if we take the second derivative, we see it to be equal to 6x. Clearly, the domain of the function f of x is set of all real numbers. Step number 2. Finding the critical numbers of the function means we have to set the first derivative to 0. Clearly, we can easily solve for the value of x by factoring, and we see that since negative 1 and 1 is in the domain of the function, they are the critical numbers of f. Moreover, since the first derivative is a polynomial, its domain is the set of all real numbers, hence it is defined for all x in R. Step number 3 tells us that we have to find for the possible points of inflection for the function. Analogously, we have to set the second derivative of f of x to 0, and solving for x gives us x to be 0. Notice that 0 belongs to the domain of the function, and thus the PPOI of the function is x equals 0. We can also see that the second derivative is a polynomial, hence it is defined for all real numbers. We can now create our table of signs. We need to consider the points x equals negative 1, 0, and 1 that would divide our real number line. Hence, we have the intervals for the first column of the table of signs. We fill out first the second column, and doing so, we just have to substitute the values of negative 1, 0, and 1 in our original function, and we get the following. Furthermore, we can now see that since negative 1 and 1 are the critical numbers, thus the first derivative of the function is 0 at these points. And lastly, the second derivative of the function is 0 at x equals 0, since this is a PPOI. Let us now continue filling out our table of signs on the third column. Note that the first derivative is equal to 3x squared minus 3. For the interval x less than negative 1, just take any number less than negative 1 that would represent this subinterval, say negative 2. Substitute negative 2 in f prime of x, and you would see that this gives us a positive number. Now, we should consider the interval from negative 1 to 1. If we're going to take a number as a representative for this interval, say 0, this would result to negative numbers. And for the last subinterval, say numbers greater than 1, if we would take a representative and substitute it in f prime of x, we see that this results to a positive number. And for the fourth column, the second derivative of f of x, note that it is equal to 6x. And it is now subdivided into two subintervals, numbers less than 0 and numbers greater than 0. For those numbers less than 0, if we substitute it in the second derivative of f of x gives us negative results. And for those numbers that are greater than 0, we get positive numbers. Now that we have filled out the first four columns of the table of signs, we will now create conclusions based on this information. Based on the third column, which is the first derivative of f of x, we see that the function is increasing for values less than negative 1. However, the function is decreasing for the interval from negative 1 to 1. And lastly, we see that for numbers greater than 1, the function is increasing. We also see that there has been a change of signs in the first derivative of the function, from increasing to decreasing. Thus, the function has relative maximum. And there has also been a change from decreasing to increasing at x equals 1. Hence, at this point, we see a relative minimum. We will now draw conclusions using the second derivative of the function. we see for the numbers less than 0, the function is concave down. And for the numbers greater than 0, our function is concave up. Since there has been a change in concavity, our function then has a point of inflection at x equals 0. From this, we can now start graphing our function. We will begin by plotting the important points we got using the first two columns. We have -1, 4, 0, 2, and 1, 0. These points will now give us an idea on how high or low the function may attain. We will continue our sketch by looking at the first three rows of the table of signs. We see that on the first row, the function should be increasing and concave down, and on x equals 1, the function attains a relative maximum. It should have a change of direction, and thus, the function begins to decrease on the numbers greater than -1. Moreover, the function is concave down throughout these intervals. Now let's continue looking at the next rows. For numbers -1 to 0, we see that the function is still decreasing, however, it is concave down. At x equals 0, it will continue to decrease, but it will change its concavity since it is a point of inflection. Thus, for numbers greater than 0 to 1, the function will continue to decrease, but the function will now have a different concavity and it will now be oriented as concave up. Lastly, as we have seen in the previous row, we know that the function is still decreasing for the numbers from 0 to 1, but is oriented as concave up, but we see that for x equals 1, it is a relative minimum. Thus, the function changes its direction and it now begins to increase for the values x greater than 1. And its orientation, being concave up, still remains. And thus, we have the sketch of the graph. And since this is a line, it is important to write the arrowheads for the endpoints. Congratulations! You were able to graph the function f of x equals x cubed minus 3x plus 2. Again, to sum it up, here is a strategy for sketching graphs of functions. Take its derivative and domain, find for the critical numbers and possible points of inflection, create your table of signs, draw conclusions using your table of signs, and begin sketching the graph of the function. Before we end this video, I'd like to give this challenge and graph the function f of x is equal to 3x to the 5th power minus 20x cubed. I know you can do and simulate the processes as well. Good luck and have fun graphing this function. See ya!